Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be talking about GCSE Physics content for paper 2. In the previous videos where I have touched on energy, such as energy stores and things like this, that is more of a paper 1 topic. So I'll leave some links for you if you haven't yet checked those out. However, this is more paper 2 content where we're looking at work done and energy transfers, and we're going to do some calculations as well. So I hope you do enjoy it. If you do, please give it a big thumbs up, share this with someone else, and do subscribe if you haven't already. And thank you so much for your support. So with any of my videos, you have probably seen this before. If you haven't, this is very much what I always say in real life and also in videos as well. If you're ever doing calculations in science, always make sure if you type it in your calculator, you write it on your paper. If you type it, you write it, okay? Because if you make a mistake, you actually will get marks if you kind of use the right methodology, especially at GCSE. If you have a long answer question, maybe it's worth 5 marks. These ones are only worth a few marks, granted, but those longer answer questions where they're worth a bit more because there's multiple steps to the calculation, that's really important you show you're working out. So it's good habits to maintain throughout your GCSEs, and also if you are looking to do A levels as well. Remember, we're scientists here. We always want to show our method and working out so that we can kind of help other people understand what it is we're doing, and it's all about communication in science. So it's a really good skill to have. So yeah, you will need a calculator for these sorts of things. In the exam, you are given an equation sheet. You will be given this equation in the exam, so you don't necessarily need to remember it. However, you do need to identify it and also remember the units. So it's a really important part of the curriculum that we can revise now together. So what actually is work? Well, work is essentially a type of energy. When a force causes an object to move a certain distance, work is actually done on that object. So you require essentially some energy to actually move an object through that distance and apply a force to it. And we can calculate work done. Work done is measured in joules. It's a type of energy, like I said. It also can be measured in Newton meters. Remember, 1 joule is equal to 1 Newton meter, so it's quite easy to convert between the two. And work done is equal to the force in newtons times the distance in meters. Now we can give this equation some symbols, and in the exam they will give you, like I said, this on an equation sheet, and the symbols will be work done, which is W, equals F for force and S for distance. Now it can be a bit confusing in this case because actually S often stands for displacement, but distance is fine in this case too. Remember, displacement is kind of the sister quantity for distance. Displacement is just the vector quantity version. It has magnitude and direction, whereas distance is actually a scalar quantity. It just has magnitude. So let's have a go at some of these calculations. I'll give you an example here. We've got two little boys that are playing together. They're on a swing. We have one of the boys who is pushing the other one on the swing with a force of 7 newtons, and the second boy who's on the swing moves a distance of 0.4 meters. Now, when we times those numbers together, we want to make sure we write out the equation first. We put the units in the correct place at the end, and we can see that we get an answer of 2.8 Newton meters or 2.8 joules. It's really important that you underline your answer or make sure that the answer goes in the answer box in the exam, and that way you can get all the marks. The other thing they could ask you for is the units, give an appropriate unit. I've just converted it into joules in this case, and I'd recommend you do the same. Okay, so here are some practice questions for you. Definitely have a go and write your answers in the comments section. It's always great to hear from you. Thank you so much if you are doing those questions. I do get notified when you do comments, so it's always lovely to see your application there. I will also leave the solutions, as always, in the description box for you, so you can check your own answers too. Remember to write out the equation first, put the units in at the end, and underline your answer. You will have to, in each of these cases, rearrange the equation because one of them's asking for work done, one of them's asking for the force, and the other is asking for the distance. So just be very careful to make sure you are calculating the correct thing with rearranging that equation. And if you would like help and support with rearranging equations, do let me know in the comments section. I'm more than happy to make a short or a video on that to help you out. Okay, so just a last little bit of information then. Energy transfer and work. This is a bit of the curriculum where they kind of want you to know a couple of things just to recall from the previous paper. So paper 1 topics. Remember, we talked about energy stores. So energy, chemical energy, kinetic energy, elastic potential, gravitational potential. There's loads of different energy stores. Remember that energy cannot be created or destroyed. So we want to keep that idea and that thread throughout paper 2 as well. Just remember, when work is done on an object, energy is just transferred from one store to another. So one of those key examples, we've got someone that's pushing a box a certain distance. There will be frictional forces that are actually being applied to this particular object as well in the opposite direction to travel. And what they want you to know at this stage is to remember and recall that when you have a frictional force, actually it can raise the temperature on that particular object as well. And these are just some key ideas that we've already talked about, but it's worth mentioning again. And I'll link that video about energy stores in case you missed it. But for now, thank you so much for your time. I've been the GCSE science teacher and you have been curious. If you did enjoy the video, give it a big thumbs up, share it with someone else, and let me know, what are you currently revising at the moment? Are you revising paper 2 content? Are you focusing on physics or biology or chemistry? Either way, I hope your revision sessions are going well. Let me know if you have any particular questions about the GCSE exam or anything you'd like more support with. I'm always happy to help where I can. In the meantime, check out my other videos for paper 2 and paper 1 content here on my channel. I'll link some other resources in the description box as well, including the insert, the equation sheet that you'll be given in the exam, especially if you're doing AQA. I'll find the others for OCR and EdExcel as well, but they are very similar, so you'll be able to have a look and see what sorts of things you'll be given in that physics GCSE exam. In the meantime, have a great day and I will catch you